again, today we're going to learn some more about properties and how they apply to the math that you've been doing. And we're lucky because you have previously talked about properties, and so some of these ought to be pretty familiar to you. So just follow along. The first property is the commutative property, and this follows for addition or multiplication. And the commutative property states that the order of values does not matter. The order of values does not matter. So what does that look like in an example? Well, if we're adding two things, A plus B, that's the same thing as adding B plus A. Another example we could say is that 5 plus 3 equals 3 plus 5. What else? We could say A times B is equal to B times A. And then also we could say that 6 times negative 2 is equal to negative 2 times 6. The order does not matter, and that is the commutative property. The associative property of addition and multiplication says that the grouping of values does not matter. So I can have A plus B plus C and group A and B together, and that's the same thing as saying A plus B plus C, where B and C are grouped together. Notice there's no subtraction in here. This is only true for addition. And that goes for all of these. If it says multiplication or addition, that's what it's true for, not subtraction or division. Another example, we could say A times B times C and group A and B together. This is the same thing as saying A times B times C, and again, group B and C together. The next property is the identity property. Who are you? What is your identity? Your identity always stays the same. So the identity property says that everything stays the same. For example, if we add 0 to A, what do we get? We just get A. It stays the same. And for multiplication, it looks like this. We have A times 1, and that will always be equal to A as well. Next is our inverse property of addition or multiplication, and these use opposites to cancel a value. So how do I cancel out a value? What would cancel out 8? What do you think would cancel out 8 if I were to add to it? Meaning what would equal 0? And the answer is negative 8. They cancel each other out. And for multiplication, we need to equal 1. So if I have 4/5, what cancels out 4/5? The reciprocal of 5/4. Our next property is the zero product property, and this means that multiplying, or it says that multiplying by 0 always equals 0. So 17 times 0 equals 0. 5x minus 1 times 0 equals 0. Anything times 0 is 0. The distributive property is a way of simplifying an expression, and it says multiplying a value to an expression inside parentheses. So multiplying a value to an expression inside parentheses. For example, if we have 2 times x plus 7, if I multiply that times everything inside of the parentheses, 2 times x is 2x. And 2 times 7 is 14. And I used a plus because there's a plus inside the parentheses. Another example, negative 6 times x minus 3. I multiply the 6 times the first thing, so negative 6 times x is negative 6x. And negative 6 times negative 3 is going to be, or minus, negative 6 times 3 is 18. So negative 6x minus 18. None of these properties that we've talked about so far are new to you. You should have done them before. If you didn't, here's a good review for you. So now let's talk about some of the newer properties. What have you probably not heard about? And the first one is the reflexive property. And this one says a value will always equal itself. So A always equals A. 16 will always equal 16. 7x will always equal 7x. And 4y squared will always equal 4y squared. Then we have the symmetric property, which says if A equals B, then B equals A. You flip them around. So if an example would be if x equals 3, then 3 equals x. Or we could also say if 5x equals 30, then 30 equals 5x. And finally, we have the transitive property. This says that if A equals B and B equals C, then A also equals C. What does that look like? I know that those words are a little confusing. That means that if I have 4 plus 3 equals 7, and also 7 is equal to the square root of 49. Then 4 plus 3 also equals the square root of 49. These are just different ways to represent the same thing. And then we have our closure property. So you can read this. It states that a set is closed under an operation if the operation always produces an element of the same set. If an element outside the set is produced, then an operation is not closed. That is so fancy. So let's kind of look at the examples to see what that means. Example 1, integers are closed under multiplication. What this means is if I multiply an integer times an integer, will I get another integer? Will that always happen? And the answer is yes, it will happen. So that is true. Natural numbers are closed under subtraction. So what are your natural numbers? They're your counting numbers, right? They're 1, 2, 3, 4, 5, ... So natural numbers. What if I took 5 minus 2? That equals 3. So that equals another natural number. But what if I did it the other way around? What if I said 2 minus 5? That gives me negative 3. And negative 3 is not natural. Therefore, this statement does not follow the closure property. Even numbers are closed under addition. So if I add 2 even numbers, we'll always get another even number. And that is actually true. And irrational numbers are closed under division. All right, so give an example. Think about an example. Mine for irrational is always pi. So we're talking about pi. So pi divided by 3 is probably irrational. Pi divided by 2 is probably irrational. But what about pi divided by pi? Remember, anything divided by itself is 1, and 1 is rational. Therefore, that statement is false. Alright, do not worry about this screen. I'll actually even go back. This concludes the notes on the properties, and we will talk about them more in class. I hope you have a good evening, and I'll see you tomorrow.